Hello, my name is Evan Hughes, and this is my lab report for Lab 10 over semiconductor light sources. I missed this lab because I was making up Lab 9, but I made it up completely alone the next day. My TA is Sid Vatz. I am in Section 3 on Tuesdays, 5:30 to 8:20. The overview, we looked at the physical properties, the spectra, the beam divergence, and the power output versus drive current for both LDs and LEDs. For part A, looking at the LD first, we had a reference measurement of a 1 millimeter on a ruler of about 392 pixels, which gave us, after measuring, a cavity length for the LD of about 1.4-ish millimeters. And using that to calculate the longitudinal mode spacing with n equals 3.5 and the wavelength of a typical LD, we got a 0.044 nanometers, which is in the realm of a typical longitudinal mode spacing for an LD. For the LED measurements, we got the length for red of 0.82 millimeters, and blue and green we got the same at about 0.84. And using that to calculate the emission area, we got 0.666 for red and 0.704 millimeters squared for blue and green, which you can't see it, but it is in the typical emission area for LEDs as well. For part B, for our under the threshold current, we used 15 milliamps and did not get many spikes. We got a pretty rough estimate on the screen here. For the threshold, we got one spike right about here. And then once we went above threshold to 30 milliamps, we got a very large spike right there. And after adjusting our view, we could not find any other peaks, so no modes were found when we adjusted the view. The LED emission spectrum is right here. This took quite a while to get because it was pretty variable and it was hard to hold the LED in place long enough to be able to take a picture. Part C, this is our power versus the angle for the LED, and I think this is the best graph that I've ever gotten in a lab. And for our maximum voltage with the polarizer and rotating it, we got 24.6 and a minimum of 22.6, which gives us a polarization ratio of about 1.1, which makes sense because LEDs are unpolarized. For the LD with the major axis horizontal, we got a pretty broad graph here. And whenever we adjusted it to vertical, we got very sharp graph right here. And after putting our max and min with the polarizer, we got a polarization ratio of about 15. For part D, the LED power versus current, we got a somewhat linear graph, as you can see here. And for the LD power versus current, we got a pretty exponential graph. And that is it. Thank you very much.